This video will demonstrate how using mathematical software that features graphical, algebraic, and numerical representations of mathematical objects can help students understand the mathematical relationships. Here, you will see a teacher using graphing software to show students the idea of a gradient of a tangent to a curve at a point, and how the numerical value of the gradient is related to the point on the curve.
We're going to look at gradients of tangents to curves. So here I've drawn a tangent to the curve y equals x squared. I've drawn a tangent at a point and I've measured a gradient triangle, base 1 going up 2. As I move this point, you can see that obviously the tangent to the curve slopes differently. Can you turn to the person next to you now and say as many different things as you can about how this is changing for different values of A?
Rate of change of gradient is constant for a start. You can see that the gradient changes by 2 every time.
It is doubled.
How many different things can we say then about how the gradient changes? Yeah?
Well, we can see that the rate of change of the gradient is constant.
So the gradient is changing at a constant rate. Brilliant. Yeah?
As A becomes bigger and more positive, the gradient will increase.
So as A becomes large and positive, the gradient increases. Someone else, what happens when A gets negative?
The gradient becomes more negative.
Gradient becomes more negative. What I'm going to do is very quickly just tabulate some values. What's the relationship between the gradient and the x value?
2 times the x value.
It's 2 times the x value. Here's x cubed. Again, describe to the person next to you what happens to the tangent to the curve as we move along from left to right on the x value.
The gradient function is always increasing until it gets closer to 0, and when it reaches 0, the gradient function also reaches 0 because it's a stationary point.
Other things we can say, gradient is greater than 0.
Yes. Well, except for when it's at 0, because then gradient is equal to 0.
Greater than or equal to 0.
What's happening to the gradient of the tangent to the curve at a point?
Initially it decreases, and then after 0, 0 it increases again, but it never becomes negative.
Let's have a quick look at what a table of values would look like for that. As I move along, I get these values for the gradient. Anyone notice anything about these numbers in the right-hand column?
There are multiples of 3.
And they're all multiples of 3. Brilliant. I can ask the spreadsheet to do the calculations for me very quickly. C2 divided by 3. Just take a third of those values and you see that I am getting the square numbers on here. So 3x squared is going to give me the values of the gradient of the tangent to the curve at a point. What were your observations of being in the room and seeing how the students responded and how that file helped their understanding?
It certainly sped up the process. They could almost instantly see the connection between the different x values and the gradients that it then produced. And then having the table produced for you, they could see straight away how to get from the x values to the gradient.
Well, if we just got a table of values, say between -3 and 3, we wouldn't know whether it ever goes negative or not. We wouldn't know the exact shape. Well, here we can clearly see that the table, it gives us real kind of tangible numerical values. Like, we wouldn't be able to work out the actual formula for the gradient function from the graph.
Reflecting also on the questioning techniques, do you think that that got them talking in a way that you would hope they would talk to each other?
Asking them to talk in pairs about what you were doing seemed to generate a lot of discussion, certainly.
I used a prepared file. How often would you prepare a file beforehand like that? Or?
It would depend on the topic, I suppose, and quite what I wanted to do with it. If it's something simple, I can do it on the fly. Other things that maybe even take it to a new level, it may be something that I've not done myself before and don't know how to do, but I know there are other people that probably have done it, and on the GeoGebra Tube site there are loads of examples that you can use and download to use yourself.